So now we see that the formation of Grignard reagents. So for the formation of Grignard reagent, we need alkyl halide, which is Rx, and we need to add the magnesium with the presence of ether. So this will form the RMGX. So this is called the Grignard reagents. The R will be 1 degree, 2 degree, or 3 degree, or aryl halide, aryl alkyl, or X will be the fluorine, chlorine, bromine, or iodine. So thus this MgX is called the Grignard reagent, which is very important in the organic chemistry, because in the most of the cases for the reactions of preparations of something alcohol, aldehyde, ketone, we must need we need this by this Grignard reagent we can create easily, or we can prepare it easily. So here we see that the preparation of alkanes by the Grignard reagents. So we need to first select the Grignard reagents. This is also depend on which alkane we like to produce. So it's depend on the R or NX. So for X, we know that X is the halide. So there is a fluorine, chlorine, bromine, iodine, which is group 17. In this halide group, we see that there are three component we can use, because we can't use the fluorine, because fluorine is highly reactive, so it will create like a bomb. So we won't use the fluorine for the any reactions for its high reactivity. So we use generally chlorine, bromine, iodine. So in this sector, in this three compound, the Ri is really highly expensive, so it's not really available. That's why we don't use the Ri, or that means the iodide from. In this bromide from is good compromise for the price or availability. This is good for use. And RCl we sometimes use it, but it's less reactive than the alkyl bromide. So but it is easy to prepare to buy or buy, so in this chemical industries or factories. So in most of the case we use the alkyl bromide. In some cases also we use the alkyl chloride. So now the formation of Grignard reagents. Here we see that we used alkali halide with magnesium with the presence of ether. This produce the Grignard reagent, which is our main focus. So in this reaction we see that the alkyl will be our 3 headed, the alkyl maybe our 1 degree, 2 degree, or 3 degree. So in this reaction, so we decided we used the 3 degree alkyl halide, because here you see that the carbon is attached to the another 3 carbon directly. So this is the 3 degree alkyl halide, this 3 degree alkyl, this is the 3 degree alkyl. So if we replace this hydrogen with another, this will be alkyl halide. So for this, if we replace the CH3 with Cl, so this is the alkyl halide. If we add the magnesium with the pieces of ether, so this is 3 CH3, so this will form the Mg with add to the chlorine. So that's why this will form the alkyl magnesium halide, which is our main focus in the Grignard reagents are MgX. So this is the formation of Grignard reagent. We use also the 2 degree or 3 degree. So this is the, if you use the CH3 CH2 CS Cl, this is also alkyl halide, but this is 1 degree alkyl halide. So that's why this will form also the 1 degree Grignard reagent. The pieces of ether, this will form magnesium will react with attached with the chlorine. So this will form C3, C2, CH2, MgCl. So this is our Grignard reagent, MgX. We further use it to produce alkane or something organic chemical compound. So this is the mechanism of the reactions of this production of Grignard reagents. Here we see that we used alkyl halide Rx, and we used the magnesium. We know that the magnesium covalency is 2, so it is prepared to magnesium also wants to give the 2 electrons to others, so it can be from the magnesium 2 plus, which is more stable than magnesium. So that's why there is we see that the 2 electron of magnesium 2 electron of magnesium here. Or also we know that the halogen electron negativity is higher than the others. So in this bond the carbon halogen bond, the halogen also always tends to the electrons towards him, so that's why towards it, so that's why it will takes the electron from this, and this electron also contribute this. Okay, so that's why this bond is break with the equal distribution. So there is R will get 1 electron, X will get 1 electron, and X will also get the 1 electron from magnesium. So this will be from X minus, this is the magnesium, and magnesium give 1 electrons to the halogen, so that's why it is will be from the magnesium plus. And further we see that the bonding will create with alkyl with the magnesium, because we see that in this reaction the alkyl group donates the 1 electron, and also the magnesium group donates 1 electron. So this will create a one bond, single bond to each other alkyl with the magnesium. So this is our main focus of the Grignard reactions. So this is how the free radical mechanism, this free radical mechanism alkyl magnesium halide, which is also known as Grignard reagent, is formed. Okay. So in this form the alkyl in the two part, one is alkyl part, other is magnesium halide part. So in this reaction, in this compound, the alkyl is also more highly electronegativity than the magnesium halide, because we know that then this magnesium 2 plus and the halogen minus, so this total will be from magnesium plus. So this is magnesium, so mgx minus plus R plus, so R will be mg plus R minus. So here let me write again. So we know that this is our alkyl magnesium halide Grignard reagent. So magnesium is plus 2, halogen is minus 1, so the total is plus 1. So if this is plus 1, this must be minus 1 for the equality of the charge distribution. So that's why the alkyl group is here is negative charge, partial negative, and the magnesium halide is this part is partial positive. So we expect that Grignard reagents show both a strong base and also the good nucleophile. And then percent ionic character, we see that there is a covalent character, also the ionic character. So this is the two mixtures. So if we see that with the bond of the potassium, sodium, lithium, magnesium, zinc, cadmium, copper, the most reactive strongest base from lower to higher, and the best nucleophile or least reactive is from top to bottom serial. So you always use the prefer the magnesium, which has the both characteristics. That means the base and nucleophile characteristics, these two behavior in effects. So by these Grignard reagents we can produce the alkane easily. So you have to, first of all, Grignard reagents are a strong bases and react readily with a slightly acidic hydrogen, that means H plus. So this is our H plus, this is our Grignard reagent. So there will be reaction with we know that if this is partial negative, this is partially positive, so hydrogen is to alkyl for the bonding with RH, which is alkane, and the other part will be magnesium halide of partial positive charge. So by this we can easily create the alkane by the presence of the Grignard reagents. So any source of hydrogen will bring out about these reactions. If we put any hydrogen source or reactant with the Grignard reagent, so this will form the alkane. So in our daily life we see that the hydrogen sources will be water, amines, alkynes, carboxylic acids, atmospheric moistures, alcohols, acids. Any alcohol, thionyl acids or NH bonds are sufficiently acidic to react with the Grignard reagents, and which will form the alkane RH group.